Alright, hello everyone. Alright, my name is Kotora Ovo. I'm from the Information Technology Department. So I'll be the one taking you for Systems Analysis and Design, that is IIT or ICS 2204. So before we start, I understand all of you have now joined the teams where I've uploaded the course material and reading material also. Then I also want you to go to the folder within your team's platform that is labeled recordings. Then there is a folder again within that same folder, return playback software. Go and install that playback software. That's the one that you're going to use to play back all these video lectures. So I'm sure you're going to do that. And also and note that I will be grading your assignment, I think, starting next week. So make sure, for those who joined a bit late, don't hesitate to submit your assignments on Teams. But for the future assignments, I think you need to stick to due dates, because I understand all of you now at campus. So this is our first lecture, and it's our introduction to systems analysis and design. So before wasting much of our time, let me just go straight to today's business. Alright, so before we understand what systems analysis and design is, we need to understand first what a system is. So let me start by looking at what a system is, and we need to understand the importance of the systems concepts in as much as systems analysis and design is of concern. So the first definition that we have here about a system is define a system as an aggregation or assemblage of objects joined together or in some regular manner. I don't know what happens here, but we looking at aggregation or assemblage of objects. Objects, I'm sure you understand it from our programming languages what an object is. We are looking at any real world entity that we want to represent in our system. It becomes an object. Then the other definition of a system is the interaction or interdependence toward the accomplishment of some purpose. That is the second definition that we have. There is interaction, there is interdependence towards accomplishment of some purpose. So a system also, from the second definition, it is to achieve some purpose. Then the third definition, it's saying a system is a group of interrelated components that function together to achieve a desired result. And so from this, the third definition, we have introduced another term, which is components. And these components, they interact just like we have seen it from the second definition. There is interaction of objects, there is interaction of components, and these components are interrelated. That is from the definition number one, the aggregation or assemblage. From definition number two, we are looking in terms of the interaction. So let's go to the next definition of a system. Right there, it says it's a whole composed of parts in an orderly arrangement according to some scheme or plan. So we are looking at parts that are composed. It's something that is a whole, which is composed of parts. In these parts, we can refer to parts as components, as objects. But what are they doing? They are arranged together according to some scheme or plan. Then the next definition is saying a set of connected things that form a whole or work together. We have connected things that are working together, and they are connected also. Then the last definition says a set of interrelated components that work together in a cohesive manner to achieve a common goal or objective. So if we look at the first 5 definitions, I think we can actually summarize them to come up with one congruent definition of a system, which says a system is a set of interrelated components. And what does these components in their interrelatedness do? They work together in a structured way. And what are they? Why are they working in such a way? They need to achieve a particular goal or objective. So those are the systems that we want to look at. Be it, for example, a computer system. We look at a computer system. It's a set of interrelated components. We have the keyboard, the mouse, the network cables, the Wi-Fi, the whatever. Those components, they work together to achieve a particular goal. So any system that we're going to be looking at in as far as in this courses of concern, we want to look at a system that is some interrelated components. And those components must be working together. And how they are tied together, it depends from system to system. But at the end of the day, any system that we're going to be analyzing and designing, it should what? Achieve a common goal or objective. So basically, that's the definition of a system. Of course, we're going to be looking deeper into the structure of a system, what makes a system, the characteristics of the system, etc., etc. So let's proceed. So we look at various definitions of the word system, but most of them, they seem to have a common idea that suggests that it is an orderly grouping of interdependent components linked together and according to a plan and to achieve a common goal. So basically, we have those three main characteristics of a system. We have interdependent components that are grouped together, not just grouped together, but there is a particular plan or particular scheme. And at the end of the day, they are, according to that scheme and according to that interdependent grouping, they have to achieve a particular goal. Now, the word component may refer to physical parts, which might be engines, wheels of a car, etc. Of course, we can look at a car in terms as a system. The goal of a car is to take you from A to B. What are the components of a part? We talk of the wheels, the steering, the seats, etc., etc. Then they can also refer to managerial steps such as planning, organizing, controlling, etc., etc. Or it can also refer to a subsystem in a multi-level structure. So the word component is not only limited to physical components, but we are looking what exactly a system is composed of. Of course, systems, they differ from one system to other. Other they have physical components, other they have organizational structures, others have multi-level structure. So components may be simple or complex. They may be basic or advanced. So example components can be a single computer keyboard, memory, and printer, or a series of intelligent terminals linked to a mainframe. In either case, each component of the total system has to do its own share of the system to achieve the desired component. So whenever we have those components working together, obviously we need to define what is the goal they have to achieve. What defines what a system is and what a system should do. Now let's look at the basic components of a system. Right, let's look at number one is what we call an entity. An entity is an end object of interest in the system. Right, for example, in a factory system, departments, orders, parts, and products are the entities. We can also look at an example of a banking system. We can talk of entities as the bank teller, the ATM itself, the chairs, or whatever. These are the entities in a banking system. Then, each and every entity in a system has what we call attributes. These are what we call the properties of an entity. For example, referring to the factory system mentioned above, quantities of each order can be an attribute. Type of part, the number of machines in a department can be attributes of a factory system. Then, I have also given an example of a banking system. The number of bank tellers, the bank teller's name, the role of the people in there, the bank manager, the cleaner, whatever. Those, the names, the roles, the number of people, whatever. That can be also what the attributes of those entities in a banking system. Then we have what we call an activity. An activity is any process causing challenges in system. It's called an activity. Any process that can cause a change in a system, that's what we call an activity. For example, manufacturing process in a department. Once we start manufacturing, it causes changes in the system. Then I also referring to the bank as a system. The arrival of a customer, it causes changes in the system, or the departure of the customer from the bank, it causes changes in the system, and we call that what? An activity. Or still referring to the bank as a system, the process of withdrawal is complete. It causes changes in the banking as a system. Then it becomes what? It becomes an activity. Now, let's look at what we call the state of a system. The state of a system is defined as the collection of variables necessary to describe a system at any given time, relative to the objective of state. For example, let's look at the bank as an example. The state of the system, we might be looking at the number of people in the bank, maybe in the queues, the number of the tellers that we have. What are the variables that can actually describe the system at any given time relative to the objective of the study, it becomes the state of a system. So you might be given a system, for example, you might be given, say, a bus. You might be required to identify the entities. A bus is a system. Can you identify the attributes? Can you identify the activities? Can you identify the state of the system? At any given time, how can we describe, or how can we have the collection of variables that are sufficient enough to describe the system at that given point in time? We can talk of the number of passengers, seated passengers, standing passengers, whatever. All those variables, if collected together, we can collectively define the state of the system. And now we are still also continuing with what? The components of a system. So, in other words, the state of the system means a description of all the entities, attributes, and activities as they exist at one point in time. So that's how we define the state of the system. Now, the next component of a system is what you call an event. An event is defined as an instantaneous occurrence that may change the state of the system. An instantaneous occurrence that may change the state of the system, it becomes what? It becomes an event. Then we also have the system environment. This refers to the external components which interact with the system and produce necessary changes. So a system, it interacts with what we call the environment. For example, the banking sector, or a bank as an example, we can say the customers, or where the customers can flow, or the constituent, that way we can say we can actually pick a customer that can visit the bank. It becomes the environment of what? Of that system. Say, for example, we have a school, say in a Belvedere. Where do we expect the students to come, maybe say to Westridge? We can have students as far as Harare, as far as Bulawayo. It becomes the system, what environment, where we can actually derive entities that can come to interact with the system. It becomes the system, what environment. But for example, if we have a school that can only take Zimbabwean students, then the Zimbabwean boundary, it becomes the system environment for what? That particular system. So we are giving here an example of the factor system. So the factors controlling arrival of orders may be considered to be outside the factor, but yet part of the same environment. So just like as I was mentioning in the example that I've given, if we're having a school, or if maybe a particular department only takes orders from its particular province, that province becomes what? That province becomes what? The system environment. Now let's look at another two types of events that can occur in a system. We have what we call endogenous and exogenous activities. So the term endogenous is used to describe activities and events occurring within a system. So we have the system boundaries, we have the system that is denoted by the system boundary. If events occurs within the system boundary, not from outside the system boundary, it becomes an endogenous event. For example, drawing cash in a bank. Obviously, you cannot draw cash while it's outside the bank. Of course, you might draw from an ATM, but maybe if you are drawing from the cashier on a counter, it's an event that is actually happening inside a banking environment. We call that an endogenous event. Then we also have what we call an exogenous event. That is the opposite of what? Endogenous event. An exogenous event is used to describe activities and events in the environment that affect the system. A good example for the banking sector is the arrival of what? Of customers. So I think basically these are the components. These are the components of what? Of a system. So you might be, like I've already indicated on, like I've mentioned earlier on, that you might be asked to, you might be given a particular system, then you'll be asked to identify all these components of a system. So be in a position, or I might send it as a question, platform, I'll give you examples of system that I will be requesting you to identify what, but that will be your homework. If you do it, it's up to you. If you don't want to do it, it's up to you also. So now let's look at the characteristics of a system. Right, so the first characteristic of a system is organization, which implies structure and order. So we talk of components, we talk of objects, we talk of entities. Those are structured in particular plan or scheme, and that's what we call organization. That's the first characteristic of what? Of a system. Then we also have interaction. And remember from our definition of a system, we say those components, they must interact together. So interaction becomes the second characteristic of what? Of a system. Then also you have the third characteristic of a system, which we call interdependence. So we are saying these components, they work together, but there is no isolation. Each and every component, it needs input or output from the other. So basically interdependence, we are looking at how those components are linked and how they are coordinated to achieve what is the central objective. Then there is integrated. We are looking at in terms of how all those components are tied together. Of course, without being tied together, we cannot have the next what? Objective or next characteristics, which is central objective. So those successful integration produce a successful achieving of the central objective of which the system was designed for. So, which also brings us to what? To the last characteristics of a system, which is central objective. Any system, it must have central objective or objective, which it aims to achieve. So in other words, we're simply saying after organization, interaction, interdependence, and integration, those four components should bring the fifth component, which is the central objective of any given system. So basically, those are the characteristics of a system. Now let's look at the types of systems that we have. We have number one, what we call physical systems. These are tangible entities that may be static or dynamic in operation. We can look at a way of as a system. It's a static what? It's a static entity. Then abstract systems. These are more of conceptual, or these are non-physical entities, which may be as straightforward as formulas of relationship among sets of variables and models, or the abstract of conceptualization of physical situations. We can take of the Monte Carlo, whatever. Those are sort of abstract systems. Then we can have what we call a closed system. This is a system where there is no exogenous activity, and event is said to be a closed. So a system that doesn't have exogenous activity. Remember, we said an exogenous activity is an activity that occurred from within the environment, from outside the environment, sorry. So if we have a system that doesn't accept input from the environment, we call that a closed system. And such systems, they are not prone for analysis. Example, water in an insulated flask. It doesn't interfere with the outside environment. Whether it becomes cold or hot, the condition of water inside the flask will remain the same. Now, the next category of a system or type of system that we want to look at is what we call an open system, which is a system where there is exogenous activity. It also includes both exo and endogenous activities. So it interacts with the events and entities that interact from within the system, and also it takes inputs from outside what? The environment. For example, we have given a bank system. We might be having people inside the bank, they do interact, entities inside the bank. We can have people coming from outside the banking environment into the banking environment. So open systems, these are typical to those that we find in real life, and these are the subject of systems analysis. So in this course, we will be looking mainly on open systems. We don't need to analyze closed systems because there is no analysis that can be applied to it to close the system. All right, let me move on. We have also what we call deterministic systems, in which the occurrence of events is perfectly predictable. So in other words, if you get the prediction of the system state at a particular time, then the next stage can be easily predicted. So a deterministic is also, we are simply saying, once we understand the nature of the system, we can tell which event is likely to occur next. Then we have also a probabilistic system, I think it's also called a stochastic system, is the one which the occurrence of events cannot be perfectly predicted. So we cannot predict which next event is going to happen. But for us to be able to predict which next event is likely to occur, of course, we are essence from this, deriving from the name itself, probabilistic. We are going to assign probability values to say what is the probability of a particular event occurring. Then we can also continue to what? To conditional probability. What is the probability of this event given these conditions? So basically this is another type of system, but the difference between deterministic and probabilistic is one, with the deterministic we can perfectly predict the occurrence of events, but with probabilistic we cannot perfectly predict the occurrence of events. Now let's look at the next type of a systems, which is an information systems. Of course, this is our where our trust is, because we are doing system science and design. What we're looking at mostly are information systems. And what is an information system? By definition, this is an arrangement of people, data, processes, and information technology that interact to collect, process, store, and provide as output the information needed to support an organization. So I'm sure from the definition of information system, we can actually pick out that we have some components here that are interacting. We have people here, we have processes, we have data, we have information technology. Of course, information technology, it's a broad category which might also include the hardware, the software, the telecommunications networks, etc. But all those, they interact. Not only interact, but they interact in a particular scheme or in an organized manner. And what is the goal of these? All these components are coming together. We want to process, we want to store data, and at the end, after storing and processing the data, what do you want to achieve? We want information. And what do we want that information to do? We want to support an organization. How, for example, through improved decision making based on what? On data. So that's basically the types of information system that we have. Not information, the types of system that we want to mention in this course. But since our major thrust is information systems, let's now look, let's have a better understanding of the type of information systems that we have. Of course, on this one, I'm not going to dwell much. I think you are going to cover this in your assignments. But basically, we have what you call a transaction processing system. Then also you have a management information system, a decision support system, an expert system, executive information system. So, like I said, this one is part of assignment number 1, if not mistaken. We have already covered that. So, we are going to look at that when we'll be doing our revision for what? For our assignments. Now, let's look at what we call system study. So, we have looked at our information systems, and we have looked at the systems definition. We have looked at the characteristics of a system. We have looked at the components of a system. Then we also looked at information systems and the type of information system that you want to know. But for all those information systems, what is important is to know who are the users of an executive information system. What are the inputs and what are they being used for? How does they help an organization? Which level of organization use that information for what and how? What are the outputs of such an information system? It's important that you understand that, because when you're analyzing system, you need to understand the type of information that is input, the type of data that the information system uses, what type of processing is done, what are the outputs is done. If you understand that, you can actually be able to do what they call bottleneck analysis. Now, let's look at system study. All right, system study may be defined as the study of the operations of a set of connected elements and of the interconnections between those elements. Of course, if we study a set of connected elements and their interconnections. Once we have interconnected components and their connections, if you look at our first definition of a system, it already comes down to defining what a system is. So system study, we are looking at, we want to look at how, I want to dig deep into the operations of a set of connected elements and of the interconnections between those elements. That's what we call system study. Now, let's look, or let's define what systems analysis and design is. So, systems analysis and design refers to the process of examining a business situation with the intent of improving it through better procedures and methods. So, systems analysis and design, system development can generally be thought of having two major components. That is, number one, we have systems analysis, and number two, we have system design. So it means our course is made up of number one, systems analysis, and number two, system design. So once we are done with analysis, we're going to go to design. Once we're done with design, we're going to see how we can actually maintain the systems, the analysis and the design. Of course, the design is something that is workable. We can actually work on it. Now, so system design, let's look at design first, is the process of planning a new system or replace or complement an existing system. Process of planning a new system, we can simply say we want to come up with a new system that does A, B, C, or D. Or we can say, we have been having this system for quite long. It's no longer meeting objectives as it was intended from its initial establishment. Or we can say, no, we have this system. Why can't we just have other modules of that system that is now complementing the system, right? So all those processes is what we call system design. But before this planning can be done, we must thoroughly understand the existing system and determine how computers can best be used to make its operation more effective. We might be having a problem that requires a new system, but before we say this problem requires the development of a new system, we must have a thorough understanding of the existing system to determine whether in the first place we need a computerizing system. We might try to replace a system, right? There is a red system. But before we replace that system, we need a thorough understanding of how that system works, so that at the end of the day, we mustn't produce a replica of the same system, but we must come up with a replacement and an improved version of what? Of the system that we are containing. So basically, that is systems analysis and design. Let's move on to the next. So now we want to separate how. Still, we are looking at systems analysis and design. Now let's look in detail what analysis does and what or design does. So analysis then is the process of gathering and interpreting facts, diagnosing problems, and using the information to recommend improvement to the system. So we want to understand how the system works. We want to gather facts about the system, what the users of the system are saying, what the designers are saying, what management are saying about a particular system. Then we want to diagnose the problem. Then we say, okay, fine. Let's do A, B, C, D. Let's come up with a new system. Let's replace, let's complement the system. So in brief, you can say that analysis specified what the system should do. And what does design does? Design states how to accomplish the objectives. So systems analysis and design can be also referred to as a structured process that is employed in the development of system, in the development of information systems. And it also consists of systems analysis activities and system design activities. So that's basically for today. I think for this first lecture, I think we are going to resume on our next lecture to see. We're going to expand now on systems analysis and design, but we said those are the processes that are employed in the development of information systems. So we will be looking at information systems analysis activities, system design activities until we reach the end of the course outline. All right, all said and done. Let's meet in the next lecture. Thank you.